You know the drill. You put your phone down on a pad and boom, it just starts charging. It feels so simple, right? Almost effortless. But hiding behind that simple little act is an incredible engineering revolution that is quietly getting ready for a massive leap forward.
For most of us, wireless charging is just this awesome convenience we've all gotten used to. It's clean, no more fussing with cables, and honestly, it really does feel like it works by magic. But is it? Well, as you've probably guessed, it's not magic at all. It's actually the result of some seriously clever physics and some really sophisticated engineering that's been refined over years and years. And that brilliant engineering, it is right on the verge of its biggest evolution yet. We're talking about a change that will fundamentally reshape how fast, how efficient, and just how powerful wireless charging can be. So to really get where this technology is going, we've got to start with the fundamental principle that makes the whole thing work in the first place. The big secret here is a discovery from way back in the 19th century called electromagnetic induction. Basically, if you run an electric current through a coil of wire, it creates a magnetic field. Then, if you bring another coil of wire close to it, that field actually induces an electric current in the second coil. And just like that, power is transferred right through the air. Okay, but for this to work on a global scale, you need everybody to be speaking the same language, right? You can't have one charger for an iPhone and a totally different one for a Samsung or a Pixel. And that's where the Qi standard comes in. Qi, and it's pronounced Qi, is the universal standard that lets your phone talk to pretty much any certified charging pad out there. It's all managed by the Wireless Power Consortium, which has hundreds of companies, think Apple, Samsung, Google, all agreeing on this one single way to make that energy flow. Pretty cool name, right? So here's the quick version of that energy handshake, in 6 simple steps. The pad creates a magnetic field, that field reaches the coil inside your phone, it induces a current, your phone converts that current into power it can use, and your battery charges. It's simple, it's effective, and it's universal. Now, for years, that was the standard, but it had this one really persistent, annoying problem. You had to get the alignment just right. The first big evolution, Qi2, introduced a simple but totally game-changing fix inspired by Apple's MagSafe. The single biggest, most noticeable improvement in Qi2 is magnetic alignment. So instead of fumbling around trying to find that tiny little sweet spot, a ring of magnets in the charger and in your phone just snaps them into perfect alignment, every single time. No more waking up to a phone that didn't charge all night. In that one simple change, that magnetic snap, it unlocks this whole cascade of benefits. With perfect alignment, efficiency jumps from around 70% to nearly 90%. And that means less energy is wasted as heat, the connection is way more reliable, and you get faster, more consistent charging at up to 15 watts. But that magnetic foundation of Qi2 didn't just solve an annoyance. Oh no. It paved the way for the next massive leap in power. And that brings us to the future of the standard, Qi 2.2. Okay, let's talk numbers. This is where we started. The original Qi standard topped out at a slow and steady 5 watts. You know, enough for an overnight charge, but that's about it. Then, with better tech and the magnetic alignment of Qi 2, that power tripled, bringing us to a much more respectable 15 watts. Now we're talking speeds that are actually useful during the day. And now, with Qi 2.2, we are jumping again, and this time it's a big one, up to 25 watts. We are talking about speeds that are starting to seriously compete with just plugging in a cable. This is like getting a 50% charge in the time it takes you to go make a coffee. I mean, when you look at the journey like this, it's not just a small step, it's a dramatic acceleration in power. We've gone from what was basically a trickle charge to something that genuinely makes wireless power practical for pretty much any situation. So the big question is, how do you safely and efficiently push 25 watts of power through the air? It is not as simple as just turning up the dial. The answer lies in completely re-engineering the single most critical component in this whole system, the inductor coil. And here's the crucial point. You can't just turn up the power to get to 25 watts. You'd literally melt the charger. Unlocking this next level of power requires a complete redesign, from the magnetic materials that shape the field to the very type of wire used to create it. Now, that's a fair question. To send more power, why not just use a thicker copper wire? Well, the answer has to do with some really strange physics that happens at the high frequencies used in wireless charging. It's this thing called the skin effect. At these high frequencies, the electricity basically gets into a traffic jam and refuses to use the inner lanes of the wire. It all crowds onto the outer surface, or the skin. This makes the wire act as if it's much, much thinner than it really is, which creates a ton of resistance and waste heat.
The solution is absolutely ingenious. It's called Litz wire. Instead of one solid wire, it's hundreds of tiny, individually insulated strands all braided together. This complex design is like building a multi-lane superhighway for the current, completely defeating the skin effect. And the performance difference? It is staggering. Efficiency jumps into the 90s, and the temperature rise is cut nearly in half. It is the only way to handle 25 watts without things getting way too hot. And it's not just the wire. Think of the magnetic material, the ferrite, as a lens for the energy. The charger pad needs a powerful projector lens to create and focus a strong field. But the phone? It needs a super efficient collector lens to capture that energy with as little loss as possible. They are two totally different materials doing two very different jobs, working together as a perfectly matched pair.
Okay, I know, that was a lot of physics. So what does all this advanced engineering, the Litz wires, the specialized ferrites, the magnetic alignment, what does it actually mean for you and your next phone?
Well, the promise of Qi 2.2 is actually pretty simple. A wireless charging experience that is finally as good as just plugging in a cable. We're talking much faster charge times, less wasted electricity, and because it's so much more efficient, a cooler and therefore safer charge. This isn't just a small update. This is the moment wireless charging truly comes of age.
And that brings us to one last pretty provocative thought. As wireless charging gets this good, this fast, this reliable, this powerful, it really makes you wonder, what happens to the physical charging port? Are we looking at the beginning of the end for the holes in our phones?